Hello everyone, welcome to iQuanta. My name is Nitin. I'm sure all of you are doing good. Guys, this is the fourth video of ratio and proportion topic. In the last video when we had met, we had understand the concept of the partnership with some very important question as well. In this video, we are learning one more concept of this topic, ratio proportion, which is called the proportionality or variation, right? So let's get started. So guys, first thing, that there are two kind of proportionality or variation. One is called the direct and inverse. Okay, whether they are calling it variation or proportionality, this is the same thing. Similarly, we can call it direct variation or direct proportionality, and this can be called inverse variation or inverse proportionality, right? So let's start with this. So guys, what is the meaning of direct variation? So you can say when two parameters change with the same rate is called the direct variation, and when two parameters are changing with the inverse rates, they are called the inverse proportionality. What is the meaning of this? Let me write with the symbols, with the help of the symbols, right? So let's say guys, the two parameters are A and B. If they are direct variation or direct proportional to each other, we write like this, the sign of proportionality is basically this, okay guys? This is the sign of the proportionality, right? Similarly, if we have to write inverse proportionality, how do we write? We say A is, the sign of proportional is the same, but we write here 1 upon B, right? Why? Because this is inverse variation, that's why we write 1 upon B. Okay, now as I said, what is the meaning of this? In direct proportionality, they change with the same rates. Here they change with the inverse rate. What is the meaning of this? That means guys, if let's say B is getting double, then A should be getting double as well, right? And similarly, if B let's say is getting half times, then A should be getting half times as well. If let's say B is getting triple, similarly, then A is also triple. If B is getting 1/3, A should be also 1/3. Similarly, in case of inverse, just the opposite, right? Let's say if B is getting double, then A should be getting half times, right? If B is getting half times, then A must be getting double. Similarly, if B is getting triple, it should be, A should be getting 1/3. If B is getting 1/3, A is getting triple, and vice versa as well, right? So guys, this is the meaning of proportionality, number one point, right? Now, how can we write this in the form of the equation? So yes, we can. Okay, see here we are given that A is proportional to B, so we can say that A is equal to K into B. What is this exactly? See guys, the sign of proportionality is changed to the sign of equal to, right? But because of this, we also add one proportion, one constant, which is called K over here, right? Similarly, this can be written as A is equals to K into 1 upon B, or yes, you can also say K upon B, same thing. Now what is this K exactly, guys? K is called K is called the constant, right? You can call it proportionality constant, all right? Proportionality constant. Same in case of inverse proportionality, K is called nothing but the proportionality constant. Okay, so that's the very first basic thing, right, which we understood. What next? See guys, with the help of this, we can do some ratios as well. Let me tell you how. Okay, in case of direct proportion, okay, let me write in the next line. We just understood that A is equal to K into B, right? And in case of inverse proportionality, we just learned that K is equal to A is equal to K into 1 upon B, right? So let's say guys, there is one scenario in which the value of A is A1 and the value of B is B1. So here what can we say? Okay, let's say there is a scenario in which A is equal to A1 and B is equal to B1, right? So in the first scenario, direct proportionality, we can say what? We can say A is equal to A1 and B is equal to B1. So we just did what? We substituted A with A1, B with B1 in the main equation of direct proportionality. In the same scenario, when A is A1, B is B1, I'm not writing it again. If you put it here, we'll say what? That A1 should be equals to K into 1 upon B1, right? So instead of A, we put A1, instead of B, we just put B1, just like the same as we did in the direct proportion, right? Suppose guys, we have another relation, another scenario in which now A is A2, okay, and now let's say B is B2. So what shall we say here? We can say this as A2 must be K into B2, simple, right? And here we shall say that A2 is equals to K into 1 upon B2, right? Same thing. Let's name them as equations. Equation number 1 and 2 in direct case, and in inverse proportionality also, let's call them equation 1 and 2, right? Now, everybody, if I divide the equation 1 with equation number 2, what can we just say here? See, if we divide equation 1 with 2, A1 upon A2 must be there, simple, right? And also, I'm sure you can see that the value of K will get cancelled out, right? And we can say this is B1 upon B2. All right, simple things. Okay, Now in this case, if I do the same thing, if I divide equation 1 with equation number 2, what shall we say here? We can say that a1 is to a2 is what? See, this time again k is getting cancelled, and this time here we shall write 1 upon b1 is to 1 upon b2, right? Which further can be written as b2 is to b1. Okay guys, this will be written as b2 is to b1 in this particular case. All right, what is the next thing? Suppose we take three parameters over here. Let's say there are three scenarios, means there are three values of a1, a2, a3. Similarly, there will be three values of b as well, b1, b2, b3. So what can we write here? We can this time write that a1 is to a2 is to a3 should be same as b1 is to b2 is to b3, right? And what will happen in case of the inverse variation, guys? Okay, here again, if I have three values of a, so a1 is to a2 is to a3 must be equal to what? That must be equal to 1 upon b1 is to 1 upon b2 is to 1 upon b3, right? Now a lot of people think, a lot of students think that this must be equal to what? b3 is to b2 is to b1. Well, let me tell you, this is not going to be equal to this, right guys? If you do the mathematical stuff, you will definitely get to know. If you just do the fraction, if you simplify the fractions, then you'll realize that this is not equal to b3 is to b2 is to b1, which is something which you have to be take care of, because I have seen a lot of students make this mistake and get negative marks, unfortunately, right? So you have to be careful about this. So what should we do actually, right? Suppose there are three parameters, so we should just solve the question in this format only. Means a1 is to a2 is to a3 is 1 upon b1 is to 1 upon b2 is to 1 upon b3. We should not write this. Actually, if you try to simplify this, that what it should be, okay, it will be actually b2 into b3, right, is to b1 into b3 is to b1 into b2. We can get this with using the LCM of the denominators and all, but it will take some time in converting this, and also it will take some time in solving like this. So I will suggest that we should solve just in this format, right? We should not try to convert in this, and we should not solve like this. We can solve like this easily as well. Okay guys, okay, now let's move ahead. Next time, now we'll be doing some simple kind of questions based on what we just learned. All right, so here the question number 1 says that x varies inversely as y, and if y is equal to 12, then x is equal to 4, and then find the value of y when x is being equals to 8. All right, so they're saying x varies inversely as y. If y is 12, x is 4, find the value of y when x is 8. Okay, inversely proportion. So we know what happens in inversely proportion. We just learned in the last slide, right? They are given that x is inversely proportional to y, right? So guys, you can solve this question, in a lot of ways actually. Since they are inversely proportional, we can do the ratio thing, that x1 is to x2 has to be what? It has to be y2 is to y1. Simple, right? Now let's just put the values over here, right? So x1 means the first, you can say the value of x in the first scenario, and x2 means the value of x in the second scenario, right? So x1 you can say is 4 because the value of x in the first scenario is 4, and x2 should be 8 because that is the value of x in the second scenario. Simple. Now we're asking the value of y in the second scenario, means the value of y2 they're asking, and the value of y1 means the value of y in the first scenario is given to us as 12. That's it. So okay, this is what we have to solve, a simple calculation. Once you do, you'll easily find out the value of y2 will be nothing but 6. Okay, very simple is this. All right. Okay, we can do it in another ways as well. What is the second method, guys? Okay, second method actually is based on the equation. See, we are given that x is inversely proportional to the y, right? So we can also say that x is equals to k upon y. Why this? I just did what? I just used the constant of proportionality. Simple, right? Now they are saying that if y is 12, x should be 4. So I'll just put the values of y being 12 and x being 4 over here, right? So x is 4. See, first scenario, let me, if I write this, the first scenario is what? Y is equal to 12 and x equal to 4, right? I'm just going to substitute the scenario over here. So what shall we get? We'll get what? See, x is being 4. We can say k upon y, which is 12. So value of k has to be with this. 12 into 4 is equal to 48, right? So what should be this equation, guys? Remember this equation from here with the help of the proportionality constant. This equation must be x equal to what? 48 upon y, right? This will be 48 upon y. In fact, we can also say that x into y is equal to 48, right? This can also be useful, right? This can also be used. Now, what they're asking to find the value of y when the value of x is nothing but 8, right? So let's put x equal to 8 in this, right? If x is 8, we just have to find the value of y. If I put this over here, so this should be 8 into y is equal to 48. And then we can say the value of y has to be 48 by 8, which is nothing but 6. All right. So this is how we can solve this, the same question, with the other method. You can see the answers are getting the same. And you know what, guys? This question actually is pretty easy, right? This question is pretty easy. I would say pretty lucky that we get such an easy question. Every time we will not find such kind of questions. You know why? Look at the values of x. First, the value of x is being 4, and then the value of x is being 8. That means we can simply say that the value of x is getting twice, right? The value of x is getting multiplied by 2. And remember, x and y are inversely proportional. So if x is getting twice, we can say that y should be getting half times. Very simple, guys, right? As I said, this is a very lucky question, right? Such simple values will not come always, right? If we get such kind of easy values, we should obviously try to encash them, right? Just like I'm doing. X is being twice, so y should be getting half times. Simple. The first value of y is 12, so if it is getting half times, so 12 by 2 is nothing but 6. So this is also a way of doing the same question, right? So I told you 3 methods. Third method is pretty lucky, it doesn't happen always. So you can apply the first 2 methods, any of the first 2 methods in given question. Depends, what kind of information is given. Okay, so this is the first question. Let's try the second question of the session. So this says what? This time it's saying that given that p is directly proportional to q square, and when p is given 50, the value of q should be 5. Okay, there are 3 questions. The first question says to find the formula for p in terms of q. Okay, the second says find the value of p when q is 3. The third says to find the value of q when p is given 200. All right, so first thing they are saying that p is directly proportional to q squared. Okay, guys, let's write this. P is given directly proportional to the q squared. Perfect. Now we have to find a relation. The first question says to find a formula of p in terms of q. How can we do that? So I'll be writing this in form of the equation. Remember I told you what in the first slide? When we have to write in terms of the equation, we change the proportionality sign with equal to sign, but we also put a constant in any of the sides, whether in the left side or the right of the equation. Usually we put the constant in the right side, but yes, we can put any of the sides. Simple. Okay, so p is nothing but k into q squared. Now remember, guys, we are given in the beginning that if p is 50, q should be 5. So let's substitute the values of p and q over here, right? So p should be 50 and q is what? Q is basically 5, so we can say 5 into 5 or 5 squared, right? So we can say what? K should be 50 upon 25, which is basically, we can say 2, right? The value of k comes to be 2 in this case. Now if I put the value of 2, k over here, we get the equation among p and q, right? We can say p is equal to 2 into q squared. So this we can say the formula for p in terms of q. So that is the answer of the first question of this, set. We can say that, right? Coming to the second question, they are saying find the value of p when q is being 3. Very simple now. We just have to put the value of what? Q, and we'll get the value of p. Very obvious. So let me do that. Let's put the value of q to this, which is 3, right? So p should be how much? Let's see that, right? Putting q 3 squared. So 3 squared is 9 into 2 being 18. Very simple. So this is how, we got the value of p. Simple. Now let's try to solve the third question, which is also very simple after this. Now they're asking find the value of q when p is being 200. So putting the value of p with this, and we'll easily get the value of q. Simple, right, guys? So let's put the value of p 200 over here. It should be 2 into q squared. That means q squared has to be 100, right? And then we can say q has to be 100 the square root of 100, and then we can say q being 10. That's it. So this is how we solve these 3 questions of this set easily. All right, so that's the second question of this concept. Let's move to the third one, guys. Now we talk about the word problems, because ultimately in our paper they ask the questions of qt in the form of the di. There will be a lot of language which will be also will be also doing a lot of di sets, right, after we finish all the concepts of the topics, right? So let's try the third question now. Third question says what? The cost of the diamond varies directly with the square of its weight, and if the weight of the diamond is 10 grams, the cost has to be rupees 1500. Okay, now the question is that find the weight of the diamond whose cost is rupees 6000. All right, so remember the relation. They're saying the cost varies as the directly varies as a square of its weight. That means cos is directly proportional to the weight square. That means W is squared. Simple, right? Okay, directly proportional. So if you have to remove this sign of the proportionality, we can say C is equal to K into W squared. Simple, right? Now remember, guys, they are saying that if the weight is 10 gram, the cost of the diamond is 1500, right? So we'll just put these values over here, right? Let's put cost as 1500 and the weight as 10 grams, right? So 10 into 10, or you can say 10 square, which is obviously 100. So 1500 upon 100 is simply K coming 15. Simple things, right, guys? So the value of K comes to be 15 in this way, and now we can do what? We can put the value of K to the original, equation which we had framed, and now the equation can be written as that C is equal to 15 into W square. Okay. Now they're asking the weight of the diamond whose cost is 6,000. So we'll put this cost 6,000 over here to put the value of, to get the value of the weight W. Simple, right? So the cost is being 6,000. Let's put it over here is equal to 15 into W squared. Simple. So guys, W squared should be what? We'll say 6,000 by 15. And 6,000 by 15, very simple calculation. 60 by 15 is 4 into 100, that should be 400. And now if you do the square root of this, the W should be nothing but, we'll say 20 grams. And that's how we can solve this question as well. Okay, guys. Okay, so I solved this question with the help of this equation method, but yes, we can solve this with the help of the ratio as well. Let me show you this. If you have to solve with the ratio, we shall say what? See, C cost is proportional to the W square. Now we can say what? Since they are directly proportional, so we can say C1 is to C2 is W1 is square is to W2 is square. Okay, guys. So now we can just put the values, right? We know both the cost. We can say what? See, first scenario is the weight is 10 and the cost is 1500. So this should be W1, this should be C1. In second scenario, the cost is given, weight we have to find. So cost of the second scenario will be written as C2 and the weight which you have to find should be in the equation as W2. So let's just put the values, right? So what shall we say? C1 is what? 1500. C2 is what? 6000. Simple, right? And W1 is what? W1 we can say is 10 square, and W2 is something which you have to find it out, right? So 1500 upon 6000, first we can say is 1 is to 4. 10 square is obviously 100 is to W2 square, okay? Now if you want, you can write in the mathematical form 100 upon W square, right? W square goes to this side and 4 comes to this side, so W2 square is obviously how much? This is W2, right? So W2 square should be how much? 400. And again, if you do the square root, W2 will be 20 grams, right? So you can see that the answer is being the same in both the methods, has to be same obviously, right? So this question also we can solve in any of these two methods, whichever you guys are comfortable in, okay? So in this note, at that note, let's go for the next question. One more question, the word problem, actually similar language to the last problem, but it has a lot more things to solve, right? Now this time let's see the question quickly. It says what? The cost of the diamond varies directly as the square of its weight, okay? Now they're saying once this diamond broke into the 4 pieces with the weights in the ratio 1 is to 2 is to 3 is to 4, when the pieces were sold, the merchant got 70,000 rupees less. Question is to find the original price of the diamond. Very interesting question, right? Okay, first relation is the same, that the cost varies directly as the square of its weight, right? Then they are saying that once this diamond broke into 4 pieces, okay, with the weights in the ratio 1 is to 2 is to 3 is to 4, they are saying when the pieces were sold, the merchant got 70,000 less as compared to the whole diamond, when it was being sold, right? So question is that find the original price of the diamond, okay. So one thing is again the same, that cost varies directly as the square of the weight, okay. Now they're saying the diamond broke into the 4 pieces with the weights in the ratio 1 is to 2 is to 3 is to 4, right? So we can do one thing, guys, we can just assume the weights, right? So we have 4 pieces, right? Let's say the weight of the first piece W1 is 1 gram. Let's say the weight of the second piece W2 is 2 gram. Let's say the weight of the third piece is 3 gram. Let's say the weight of the fourth piece is 4 gram. How did I assume 1, 2, 3, 4? With the help of the ratio. Guys, the ratio is 1 to 2 to 3 to 4. So let's say the weights are in the 1 gram, 2 gram, 3 gram, and 4 gram with the help of the ratio. So remember, this is the pieces of the whole diamond, right? So what should be the weight of the whole diamond, by the way? In this way, guys, we can say, the weight of the whole diamond, right? We can say is W1 plus W2 plus W2 plus W2 plus W3 plus W4, right? And that gives you how much? See, that gives you 1 plus 2 plus 3 plus 4 is obviously 10 grams, right? That means the weight of whole diamond should be 10 grams, simple. Now we can use the original, relation between the cost and the diamond, cost and weight, right? To, further look at this question, right? Remember, guys, cost is proportional to the weight square. So always we can write this in the form of the equations that cost is K into W square, right? So what should be the cost of the first piece whose weight is 1 gram? Let's see that first, right? So we can say the cost of the first piece is C1 is equal to K into W1 square. This is how we can write. Similarly, what should be the cost of the second piece? We can say C2 is equal to K into W2 square, right? Similarly, what is the cost of the third piece? We can say C3 is equal to K into W3 square, right? And the cost of the fourth piece, C4 is equal to K into W4 square. Simple, right? Now, putting the values of W1, W2, W3, W4 in all of them, right? So C1 has to be how much? We can say what, guys? See, K is K, W1 is being 1, 1 is square, right? Similarly, here we do put the value of W2, which is 2 grams, so 2 is square, simple. This is what? W3 square, W3 being 3, so 3 square, W4 being 4, so 4 is square, perfect, right? Now we can find these costs one by one, right? So we can say C1 being K, right? 1 square is 1, obviously. C2 being 4K, because 2 square is 4, obviously. C3 must be 9K, and C4 must be, 16K, simple. So guys, what should be the combined cost of all these pieces, right? So this should be what? You can just add them all, K plus 4K plus 9K plus 16K. What it should be? Very simple, guys. K plus 4K is 5K, 5 plus 9 is 14, 14 plus 16 is 30K. So the sum of the cost of all these pieces being 30K, right? By the way, what is the cost of the whole diamond if, let's say, it was not being broken into the 4 pieces? Now, guys, remember the weight of the whole diamond is 10 gram, right? All because of the assumption, right? So what should be the cost of the whole diamond if I have to find it out? So I'll just put the value of K as 10 gram this time, right? Because the original weight of the diamond is 10 grams, right? And this will come up as 100K, okay? So guys, try to understand, if it was being sold as a whole diamond, the cost is coming 100K, right? And if it is being sold as a as in terms of the pieces, then sum of the cost of all the pieces is coming as 30K in the assumption, right? So how much loss is he making, right? So understand, if the diamond was being sold as a whole, the cost is coming 100K, and if it's being sold as a pieces, right, then sum of the cost of all the pieces is coming 30K, right? So how much loss is he making? We can say he's making the loss of 70K, isn't it? 100K minus 30K is 70K. But in the real language, they are saying that the merchant is making the loss of 70,000, right? So in the assumption, it's 70K, but in the real, it's 70,000. So we can say 70K is equivalent to 70,000, right? So we can also say the value of K, 70 got cancelled, the value of K being 1000, simple. Now look at the question, they're asking the original price of the diamond. So what is the original price of the diamond? We just assumed as 100K. Remember, guys, original piece of the diamond we assumed as 100K. So K is being 1000 and cost is being 100K. Just put the value of K over this. So this should be 100 into 1000, right? Which we can say as 10 raised to the power 5, or you can say 1 followed by 5 zeros, or we can say 1 lakhs. So this must be the original cost of the diamond if it was being sold, without making the pieces. Simple. So this is how we can solve this wonderful question, right? Guys, obviously you do not need to write so much because I had to explain. That's why I have written that much. Yes, if you understand this question and if you get this kind of questions again, you do not need to write everything. You can do a lot of things in your brain. Simple. Okay, on that note, let's try to understand the next concept. Okay, guys, the next concept is about the mixed variation. Okay, so we learned about the direct variation, inverse variation. Now, what is a mixed variation? As the name suggests, right, mixed variation, when there are a lot of variations happening together. So first case I'll be taking when there are, you can say 2 direct variations are happening, right? Second case will be understanding something else, right? So in this case, guys, I'm assuming, as I said, I'm going to take 2 direct variations happening together, right? So let's say, guys, we are given that A is proportional to B, right? and we are also given that A is proportional to C, right? We are given both of these scenarios, right? We are given A proportional to B as well as we are given A proportional to C. So what happens in this, right? Then you know what happens? Then we can say that A is proportional to, B into C, right? So this is something given to us. A proportional to B and A proportional to C is actually given. Then by the help of these two, by the help of these two, we can say what? That A is proportional to B into C, right? Let me write this. By 1 and 2, we can say A is proportional to, B into C. Okay, simple. Now, what can we do with the help of this? If that happens, guys, if that happens, then we can follow the same thing which we have learned in the very first, slide of this session, right? Where I said the proportionality can be interchanged with the equation by substituting proportionality sign with the equal to sign and a constant at any of the sides, right? Where k is again the same thing, guys. K is what? K is a sign of proportionality, very obvious, right? Now, again, I do the same thing. Let's take a few scenarios. Let's say the first scenario in which the value of A is A1, okay? The value of B is B1, and the value of C is C1. So we can say what? That A1 has to be, K into B1 into C1, all right? Similarly, the second scenario, when I say that A is being A2, B is being B2, right? And C must be, we shall say, as C2, right? So we can say that A2 has to be, K into B2 into C2, right? Simple. Now, let's call them equation number 1 and 2 again, right? Now, if you just divide these two equations, so what should happen, right? Let's write over here. If I divide equation 1 by equation number 2, so we can say left side is A1 is to A2, right? And in the right hand side, K must be cancelled out. And remaining thing we can say that B1 into C1, right, is to B2 into C2, right, guys? And yes, in terms of the fractions, we can write that A1 upon A2 should be B1 upon B2, okay, into C1 upon C2, right? So this is what is the meaning of, you can say, when there are more than one variations happen together, okay? So that was a case of when two direct variations were happening. Now we'll understand another case in which I'll take one direct variation and one inverse variation, but that will be handled almost the similar way, right? So this time, as I said, one direct variation and one inverse variation, right? So we are given that A is directly proportional to B, and we are given what? A is inversely proportional to C this time, okay, guys? So one direct variation and one inverse variation, right? Let's call this relation number 1, let's call this relation number 2, right? Now, by the help of 1 and 2, right, what shall we say? We can say what? That A is proportional to what? A is proportional to, we'll say, is B upon C, okay, guys? We shall say A is proportional to B upon C, simple, right? Now, what next? Again, if we take a few scenarios, right? Let's say A is equal to A1. Okay, I'm taking a first scenario, simple. Oh, before that, yes, we should write down how this can be written as the form of the equation, right? So proportionality sign will get changed into the equation sign once again, and there will be one constant of proportionality, K, on the right hand side, let us say, okay? Now, if we take a few scenarios, just like the previous case, let's take two scenarios, right? This time, maybe I don't need to write. Let's say, guys, if A is A1, B is B1, and C is C1, then how it can be written? We can say this will be written as A1 is equal to K into B1 upon C1, simple, right? And second scenario, A2, B2, and C2. So this is how it should be written, right? So these are two equations, equation number 1 and 2. Now, guys, if we divide these two equations again, right? Let's say we divide these two equations. So what shall we have? We'll have that A1 is to A2 is equal to what? Is equal to, B1 upon C1, okay, is to B2 upon C2, right? This is what we can say with this, all right? In fraction form, we can say that A1 upon A2 is equals to what? Is equal to B1 upon B2, right, into C2 upon C1, right? Why? Because this was, remember in this case, C was inversely proportional. That's why it happened. C2 upon C1. Simple. Okay, guys? So that is the meaning of mixed variation. I took two cases. First case when two direct variations were there. Second case when one is a direct and second is an inverse variation, but they can be anything, and we have to deal in the similar manner. Maybe they can be three direct variation, maybe they can be two inverse variation, three inverse variation. If anything happens, you just have to do one thing. What? See, one thing should be common, that in all the given variations, only one variable should be in the left hand side. Means there should be a single you can say parameter, or variable should be in the left hand side. For example, in these two cases, only a was written in the left hand side, and the right hand side they could be anything, right? So by combining them, a will be again to the left hand side, because in these two there will be a in the left hand side. So in the resultant also a should be to the left hand side, simple. And in the right hand side, whatever do we have, for example b and 1 upon c, this should get multiplied, simple. So b into 1 upon c is b upon c, and first case what happened, b and c product is simply b into c, and a was common, so a is still here and in the left hand side, simple thing. So this is how we can deal with the mixed variation as well, simple. Now guys, let's try to apply these concepts in a few questions. So question number 1 in front of us, it says what, that x varies directly as y and inversely as z is squared. Okay, and if x is being 4, then y is 6, then z is 3. Find the value of x when y is being 8 and z is being 4. Okay, so they're saying what, x varies directly as y, inversely as z is squared. So first thing we can write what, see, we are given that x varies directly as y and inversely as z is squared. So x is proportional to 1 upon z is squared. Simple guys. This is something given to us. So by combining them by the help of these two, we can say what? We can say x is proportional to y upon z is squared. Simple. Just like the concept which I told you in the previous slide. Simple thing, right? And one more thing, next time guys, when we are given anything like this, we really do not need to write these two statements. We can directly come to this statement. If you are good with this, we really do not need to write them. Okay, from the next time we'll try to do this as well. All right, now let's try to solve the remaining things. What they are saying, that x varies, this is this. If x is 4, y is 6 and z is 3. Okay, now find the value of x when y and z are given to us. So now we can solve this in two ways again, either in form of the equations like x is equal to k into y upon z squared, or we can also solve with the help of the ratio. So you can do any of them. I'm solving with the ratio. Okay guys, I'm just solving with the ratio. So what shall we say here? We can say what, that x1 upon x2 should be equal to y1 upon y2 into z2 square upon z1 square, right? I'm solving with the help of the ratio, simple. Okay, now what should be x1? The first scenario, value of x is 4, simple. What is x2? We do not know. In fact, that is a question. Remember, we need to find the value of x in the second scenario. So x2 is something which we have to find it out. Let's write this. x1 is 4, x2 we have to calculate, right? Let's talk about y1 and y2. y1 is 6, y2 is 8. First and second scenarios, value of y. So I just write 6 upon 8, simple. What is z1? z1 is 3 and z2 is 4, simple. So I'll say 4 square upon 3 square, like this, that's it. Now guys, with the help of this, we can easily find out the value of x2, okay? Not very difficult. Let me show you how can we do. It's basically 6 upon 8, right? It's basically 4 into 4 upon, 3 into 3, okay? So 1, 3, you can say this is twice, simple. 2, cancel with this 4 times. 4 is cancelled as well. So what is we are left with? We are left with 4 upon x2 is equal to what? We are left with 1 4 and 1 3 only. 1 4 in numerator, 1 3 in denominator. So this 4 also got cancelled out, and we can say in the end that x2 has to be nothing but 3. Simple. So guys, we got the value of x in the second scenario, which is nothing but equal to 3. Okay. So this is how we solve this wonderful question as well. All right. Simple. Now let's try one more problem. Again, the word problem, which is the main target of us, right? So the question says the value of each of a set of the coins varies as the square of its diameter. Okay, if the thickness remains a constant, and it varies as a thickness if the diameter remains a constant. Okay, now they're saying if the diameter of the two coins are in the ratio of this, what should be the ratio of their thicknesses if the value of the first is 4 times the value of the second. Okay, so let's understand again. First, they are saying that value of set of coins varies as the square of the diameter. So if they are saying only varies, that means directly varies. Simple guys. Okay, whenever in the question they are saying only varies, that means directly varies. Directly varies means directly proportional. Same. So value is proportional, or you can say directly proportional to the square of the diameter when the thickness is constant. And it is varies means directly proportional to the thickness when the diameter is fixed. So there are two variations, you can see that, means again the application of mixed variation. So this time, guys, again, either we can do one thing, we can write both the proportionalities first, and then we can make the combined of them, or we can directly write the combination of them, right? We can directly write the combined result. Why should we write two extra lines? Isn't so? What they are saying, value is proportional to the square of the diameter. Okay, the square of the diameter. Let's say value is v, diameter is d, so d square into what? And it's also proportional to the thickness, right? It's also directly proportional to the thickness. So d square into t, right? We can directly do this. We should do it directly to save our time. Simple. Because both were directly proportional, that's why d square and t, they both are, you can say, in numerator, not in the denominator. Simple. Now, we are given, the ratio of the diameters, right? We are given some relation about the values, and we have to find the ratio of the thicknesses. So this question we should, try to solve with the help of the ratios. That will be, easier actually. So let's make the ratios of them. We can say v1 upon v2 is equal to what? Is equal to d1 square upon d2 square into, t1 upon t2. Simple. Okay, guys. Now let's see what ratios, what relations we are given. So they have said the ratio of the diameters are given 4:3, right? That means d1 is to d2 is given 4:3. But guys, if you look at this relation, the original relation, in this we have d1 square upon d2 square, not d1 d2, right? So we can do one thing, we can write d1 square is to d2 square as well. That should be 4 square is to 3 square. And that must be, 16 is to 9, which now we can put over here, right? 16 upon 9, simple. Okay, what next? They're asking the ratio of the thicknesses, by the way. That means obviously we do not have the thicknesses. So let's write t1 upon t2 here, okay? And they have given the value of the first is 4 times the value of the second. What is the meaning of this, guys? The value of the first means v1 is given 4 times of the v2, right? Value of the first coin is 4 times of the second coin. Okay, so we can say one thing, that v1 is to v2 has to be nothing but 4:1, right? v1 is to v2 has to be 4:1. Let's put this over here. v1 upon v2 has to be 4 upon 1. That's it. Now we can easily solve the value. We can easily get the value of t1 upon t2 as well, right? By doing some, cross multiplication. So t1 upon t2, I'm writing here, 9 goes to this, 4 upon 1 into 9, and 16 comes to this, 9 upon 16. Simple. So 4, 4, and we can say this is what? 9 is to 4, right? t1 is to t2 is nothing but 9 is to 4. So this is how we can find the ratio of the thicknesses of these two coins. Simple, guys. Alright, so this is how we can solve this question as well. And this is what the last question of this, concept. And guys, this is the last concept of this topic, ratio and proportion as well. So this is where the whole series of ratio and proportion ends. In the next video, guys, I'll come up with some more interesting concepts and topics. Right till then, you can keep watching the videos, you can keep, learning, revising, and yes, practicing the questions. Till then, bye bye, guys. Take care. All the best.